This week we've been learning about how to interpret the periodic table to figure out how many protons, neutrons, and electrons can be found in a particular element. And we've learned that when we're dealing with a standard neutral atom, that the number of protons and electrons will be the same. What this does is allows the differing charges to cancel out. So positive cancels negative, and we have an elemental form that is electrically neutral. However, most atoms in nature simply aren't found this way. They're usually combined with other elements through either the sharing or the donation of electrons in that outer layer of the electron cloud. So let's talk about that. When we have atoms that have an unequal number of protons and electrons, we call this an ion. An ion is an atom that has an unequal number of protons, which are positive, and electrons, which are negative. Positive ions would be ones that we call cations. Most of the cations that we're going to work with in this class tend to be metals that have lost some of their electrons. For example, the magnesium ion. In nature, magnesium, if it's in an elemental metallic state, will have 12 protons and 12 electrons. We can determine this from looking at the periodic table, and you'll see that Mg magnesium is atomic number 12. However, when combined in nature, magnesium loses 2 of its electrons and thus becomes positively charged. And we denote that with a 2 plus. What this is saying is that there's 2 more positive protons than there are negative electrons. So when you see in the superscript next to an atomic symbol, a symbol like this of a number and a positive or negative, this tells you you're dealing with an ion rather than an atom in its elemental form. Potassium, another metal. In nature, we normally find it combined in things like potassium chloride, potassium sulfide, and many other common chemicals. In an elemental form, because it's element 19, we would think of it as having 19 protons and 19 electrons. However, potassium, in the form that it takes most of the time in nature, is going to lose one of its electrons and thus have 19 protons to 18 electrons. So we're going to denote that by putting a plus symbol here. Now, we could make this +1 or 1 plus, but generally by tradition, if you have just one positive extra charge, you just simply put a plus symbol when I've got a marker that's running out. The iron ion. Iron metal, like the kind that you see in so many pieces of machinery, is a bunch of atoms that have 26 protons and 26 electrons. However, most of the time in nature, such as iron sulfate, which we call rust, or iron chloride, or many other common compounds, iron loses 3 electrons, so it has 3 more positives than it does negatives. So instead of having 26 protons and 26 electrons, there's 26 protons and 23 electrons. Now, some metals can actually lose more than, say, one fixed number of electrons, but we'll be getting into that later. On the other hand, we have some atoms, mostly nonmetals, that gain electrons. We call those anions. For example, the chloride ion happens when elemental chlorine, which normally in an elemental state has 17 protons and 17 electrons, takes on 1 more. And so by having 1 extra negative charge, this makes chlorine into an anion, which is a negatively charged ion, and we call that chloride. Oxygen, which is element number 8, normally would have 8 protons, 8 electrons, takes on 2 more electrons, for a total of 10 electrons. Nitrogen, element 7, takes on 3 more electrons for a total of 10 and becomes nitride. Notice a similarity here, that all of these negative ions end in I. That's just a traditional way that was developed in past years, in the early days of science, early days of chemistry, excuse me, to denote a negatively charged ion. So generally, if you have a nonmetal like oxygen, sulfur, fluorine, chlorine, nitrogen, and it gains a negative charge, you change the ending to I. So as we see here, most elements don't keep that stable, equal number of protons and electrons. More than often, we have where an element is going to combine with another element, and there will be an exchange resulting in a gain or loss of electrons. And these form the most common compounds that we'll be working with. For example, when we'll be having a lab where we're going to be burning some magnesium later this semester. What will happen is the magnesium will combine with oxygen, and magnesium will lose 2 electrons to the gain of oxygen, and we have what's called magnesium oxide. So whereas the individual atoms are no longer electrically neutral, the compound as a whole becomes electrically neutral as the opposite charges cancel out. So before we close out, let's just work through one more example here. Look on your periodic tables and take a look at sulfur. So you will see that sulfur is element 16. So how many protons and electrons would this mean if sulfur were in elemental form? You could guess correctly, they would have 16 protons and 16 electrons. But if you see this symbol, this is sulfide. This is an anion form of sulfur. So how many protons and electrons would we see here? 16 protons and 18 electrons, denoting the gain of 2 electrons. So in closing, please try to get into your mind that these 2 symbols don't mean addition and subtraction. They simply represent an excess of positive charge, protons, or negative charge, electrons. We're going to normally see metals form positive charges as they lose electrons in compounds, and nonmetals become anions, become negative charged particles as they gain electrons.